So what is the significance of these? I'm going to pull up some bullets, one after another, of things that you should get used to looking at. First of all, hexadecimal 86DD. That is the ether type field for IPv6, just as hexadecimal 0800 is the ether type field for IPv4. This is referred to as colon colon. Colon colon implies an all zeros address in the IPv6 addressing scheme. More about that and the format of many other addresses that are following on this slide in the IPv6 addressing topic. Colon colon 1 is actually all zeros ending in 1, which is the IPv6 loopback address, similar to how 127.0.0.1 is the IPv4 loopback address. FE80 colon colon /10, that is the link local address for IPv6. In a way, it's similar to the automatic private IP address that would be configured in the absence of a DHCP server with IPv4. FF00 colon colon /8, that is an IPv6 multicast prefix. 2000 colon colon /3, that is the IPv6 global unicast prefix space. Basically the block of IPv6 addresses that are being handed out and considered globally unique. Protocol number 58. That is actually the IPv6 next header value for ICMP v6. 3.4 times 10 to the 38th. IPv6 addresses have 128 bits, so 2 to the 128th is equal to a very large number. So essentially that number, 3.4 times 10 to the 38th, is the total number of IPv6 addresses available, as opposed to 4.2 billion as is with IPv4. These 5 RFCs are the base IPv6 protocols. They're the minimum required for an IPv6 implementation. RFC 2460 is the base IPv6 specification, just like RFC 791 is the base IPv4 specification. RFC 2461 is the specification for IPv6 neighbor discovery, which is similar to ARP with IPv4. 2462 is the SLAC, the Stateless Address Auto Configuration description for IPv6. RFC 2463 is the specification for ICMP version 6. And RFC 2464 is the specification for carrying IPv6 packets over Ethernet. Anycast is how we refer to an address type that is looking for the closest device to you with that address. CIDR, pronounced CIDR, is referred to as classless interdomain routing, which actually that's the structure, the hierarchical structure now for IPv4. IPv6, on the other hand, is classless by nature. IPv6's default MTU is 1280, as opposed to IPv4's default MTU of only 576 bytes. Next, we're going to look at 10 things about an IPv6 address. Just get you used to looking at them. As you can see, an IPv6 address looks pretty nasty. It's actually in hexadecimal. It's referred to as colon hexadecimal, using hexadecimal digits separated by colons to represent 128 bits, versus how IPv4 does it to represent 32 binary digits using dotted decimal. So the first thing I can tell you about that IPv6 address is it is an IPv6 address. Second of all, it's a global IPv6 address, as per RFC 3587, and I know that because it begins in either a 2 or a 3. It has an implicit structure. Again, we'll talk more about that in the IPv6 addressing topic, but we know that the first half, the top half, 64 bits, are for network, and the bottom half are for host or device, or as IPv6 looks at it, interface. You can assume that its MAC address is embedded in its interface portion. And that's because there's an FFFE in the middle. But be careful about assuming, right? And in general, you could assume that it was his burn-in MAC address. You can assume the network hierarchy, as I described with its implicit structure. It's definitely not a multicast address. It doesn't start in FF. It's also not a link local address. It doesn't start in FE80. It's not an IPv4 address. Okay, maybe I'm stretching to reach 10. There's one thing about it, and that's for sure, it's confusing.